Okay, we're going to get into solving the angle between two vectors, but before we do that, I'm just going to do a very quick question. One of the questions asked us, and they give us this parameter. This is not what the title is, but it says magnitude of A is root 7, and they want us to calculate A dot A, the dot product of A. Okay? Well, what would the angle be between A and A? And you know what the angle is between A and A? What is it? Someone's saying it very lowly. 0. It's a parallel vector, and it's a vector right on top of itself, so the angle of that vector is 0, essentially. So when we go and multiply this, we know we're multiplying the magnitude of A times the magnitude of A times cos theta. Well, theta in this case is 0, so cos 0. The magnitude is root 7 by root 7. What's root 7 times root 7? 7. Anyone know what cos 0 is? 1. Put it in your calculators, try it out. Cos 0 is 1. 7 times 1 is 7. Okay? Just wanted to draw that in case they asked you to multiply a vector by itself. Okay, let's get to the actual title here. Title is solving the angle between two vectors. So, let's get into that actual question. So, they've given us, this is example 3 in your textbook. It says vector A. So vector A, sorry, not vector A, but if this vector, which is the resultant of vector A plus the scalar 3b, and the other vector, which is a resultant of scalar 4a minus vector b, and it says that the resultant vector, or these two vectors, is perpendicular. So these two vectors are perpendicular to each other. Okay? And it also says that the magnitude of A is equal to 2 times the magnitude of B. So they've given us all this. It says determine the angle between the two non-zero vectors, which are these two. Between the two non-zero vectors. Okay? So, what we're going to be doing in this question, or sorry, the two non-zero vectors A and B. So we're looking for the angle between vectors A and B. So, we know that two perpendicular vectors, what are they equal to? Anyone remember? What's the dot product of two perpendicular vectors? 0, okay? Because we know they're 90 degrees. 90 degrees, cos 90 makes a 0. So let's write this formula out. We're looking for the dot product of A and B. We're trying to solve this. And the reason we're using this formula is because we know that cos theta, or the angle between those two vectors, is involved in the formula, cos theta. We're looking for theta, or the angle between those two vectors. Okay? So what that means in this question is the dot product between these two vectors here is going to be equal to 0 because they're perpendicular to each other. So that means vector A plus 3b dot product 4a minus b dot product is equal to 0 because those two vectors, or those two resultant vectors, are perpendicular to each other. So because they're perpendicular to each other, we're going to try working them out here. Now, this is distributive property. Hopefully you guys remember this from maybe grade 10 or 11. They also call it FOIL or the rainbow method. We need to multiply the numbers in the first brackets by both numbers in the second brackets. If you guys remember that, it's a distributive property rule. So essentially what's happening is we're doing vector A dot product of vector 4a plus vector A dot product of negative vector B plus vector 3b, dot product of 4a, plus 3b, dot product of negative vector b. And we know it's still all equal to a question 0 here. What we're going to do is we're going to combine some things. Sorry? Oh, okay. So what we did to get these numbers is these numbers here, or FOIL, that's what this is. This is the equivalent on this side. So the 0 comes down, that side of the equation. And what I did is I wrote them out. I did A times 4A, which is my A times 4A, which is our first one. I then took the A, and I knew I had to multiply it by the negative B. So I just added A times the negative B. Pardon? How did we get 0 here? Because these two vectors themselves, it said in the question, were perpendicular to each other. So because they're perpendicular, we know that when we find the dot product of the two of them, it is going to be equal to 0. So we use that information to reverse this and find out what theta is going to be in the end. Sorry? Well, I didn't actually move from this. This is just the formula. I then plugged values in. What these two are is this essentially represents the A in the above and the B in the above. And I know this entire side, because they are perpendicular, is just going to be 0. So that became the 0 here. Okay, that's how we got all those numbers. So the next step here will be to simplify what we have. Well, 4 times the absolute value of A, or not absolute, vector AA, and that is going to be 4 vector A squared. Right? The two A's multiplied by each other is the same as the magnitude squared. A times B is essentially going to be negative AB in this question. In the next one, we're going to get 12 vector A dot vector B. And finally, in the last one, we're going to get negative 3 absolute value of B squared. Essentially, the B's are going to become squared in our question. Now, above what they said was that the absolute value of A, okay, the absolute value of A in these questions is the equivalent of 2 times the absolute value of B. So what we're going to do is we're going to plug in, or sorry, first we'll simplify what's in the middle here because these are like terms. This becomes 11 AB. This is 3 B squared, still all equal to 0. And this one is 4 absolute value of A, B, positive 11. Okay. We're going to replace, because the question said the absolute value of A is equal to 2 times the absolute value of B. Okay. We're going to replace the A's in this equation with what we have here, essentially 2B. Okay. So this becomes, is that the number 4? Yeah, 4. And inside of here, we end up getting 2 absolute value of B squared plus 11 absolute value of B dot B minus 3 squared equals 0. Okay. So what we've done is we've placed all of the A's in the equation with the idea of B here. Okay. So when we do that, we're going to simplify what we've got in these two questions here. So this one here is going to become 4, and we get 4B squared plus 11 okay, so I jumped ahead a little here. This is where the mistake was that I made. Okay, this is why it's so important to recognize what symbols we're working with. This is the symbol absolute value of A. Okay, this is vector A, and what I had made the mistake of is I replaced vector A. I replaced vector A with 2 absolute value of B. But that wasn't what vector A was equal to. Vector A, we actually don't know what it's equal to. Only the absolute value of vector A, or the magnitude of vector A, could be replaced with that. Okay. So what we actually needed to do is this here is A dot B again. So because we were working with magnitudes at the end, 4A squared and 3B squared, okay, and this is the absolute value of both of these, what I want to do is I want to turn these two vectors into absolute values. And the way we can do that is we know from our original equation way back here is A dot B is equal to the absolute value of A times the absolute value of B times cos theta. So that's why we were having a little trouble. I knew we should have gotten a cos theta in there somewhere. Our AB, we're going to now replace that. So I'm not going to do anything else, but in the next step, this still becomes 4 absolute value of A squared plus 11. I'm going to replace the AB with that equation of absolute value of A times absolute value of B cos theta minus 3 absolute value of B squared equals 0. I apologize. Now that they're all the absolute value, we can go about replacing our absolute values of A with what we had above, 2 times the absolute value of B. So this does then become 2 times the absolute, that should be a B in there, absolute value of B squared plus 11 times 2 times the absolute value of B again, okay, times the absolute value of B again, cos theta minus 3 absolute value of B squared again equals 0. Okay. Now we can go about start simplifying the middle. First of all, this in here is going to become 4 times 4 absolute value of B squared plus we're going to do 11 times 2, which will give us our 22, and this again becomes absolute value of B squared. We're doing a B times B, but is also multiplied by cos theta. And our last one, we have 3 times the absolute value of B squared equals 0. This becomes 16 squared plus 22 B squared times cos theta minus 3 squared is equal to 0. You guys follow so far? Let's know, maybe so. Okay, here's our tough part. Our two like terms are 16b squared and negative 3b squared. The 22b squared is not technically a like term. Anyone know why? What's that? Because the cos is attached to it. In other words, it's multiplied by cos theta. So we can't multiply those in like terms. So what I'm going to do, because remember our goal was to find out what the angle between the two were, is I'm going to move that term to the other side of the equation. So when we move it to the other side of the equation, I'm going to equate 16b squared minus 3b squared. Anyone know what that is? 13 vector b squared, magnitude vector b squared, is equal to, when I move this over, it comes negative 22 squared cos theta. Now again, our goal is to solve for cos theta. So how can I move negative 22b vector b squared over? I'm going to divide. 13 vector b squared is equal to cos theta, as long as the 13b squared is divided by negative 22 vector b squared. Okay. Now I have vector b squared divided by vector b squared. Anyone know what that'll equal? Cancel. It technically makes a number. Anyone know what number it does? 1. It technically makes the number 1. Okay? But for our argument's sake, we're going to cancel these two out. And we're now left with 13 divided by negative 22 is equal to cos theta. Theta is equal to the cos inverse of 13 divided by negative 22. Anyone know what that is? What is it? 126. 126.2 theta. So, a difficult question. 3 is a long question in order to solve.